Hi, this is Phil at Simply Rhino, and in this short video I'll be looking at setting up an interior render in Rhino 8. I've already set up an interior view and saved this as a named view, but let's start by looking at a method by which we can set up this type of view and how we can then save it. I'm going to right-click here to run 4 default viewports, which will reset all the views to the Rhino default. Next, I'll set the ortho viewports to wireframe and the perspective view to shaded. I'll create my new interior view in the perspective viewport, and one method is to visualize the camera widget that is driving this perspective view, and then move this widget in the ortho views to position it precisely. To visualize the camera, I'll make sure the perspective viewport is active and use the F6 shortcut. If I now zoom out a little in the ortho views, the camera object becomes visible, and I'll see 5 points that can be adjusted. The camera location point is the camera itself. The camera target is the focus of our view. The camera midpoint facilitates moving the camera and target together. The camera corner point controls the field of view or lens angle. And the camera up point controls the roll or tilt of the camera. My personal preference is to move just the camera location and camera target points and then set the lens length and projection in the viewport properties panel. My suggestion here is to select all of the layers that include any geometry and then lock them to make sure that I don't inadvertently drag any objects. Turning off ortho and disabling the object snap will also make it much easier to manipulate the camera. Now, working in one ortho viewport at a time, I'll position both the camera and target points inside the building in each of the 2D views, and gradually the interior perspective view will be resolved, and I can start to move the camera about inside the building. The view is very tightly cropped at the moment, and this is because the camera is using the standard lens length. If I make the perspective viewport active and go to the Viewport Properties tab, I'll see that the lens length is set to 50mm. The metaphor being used here is that of a 35mm film camera, or, in digital terms, a full-frame SLR or mirrorless camera, where a 50mm lens creates the closest field of view to a human eye. I'd like to reduce the lens length here to create a wider angle view. So if I set this to, for example, 28mm, the view widens out and I can keep decreasing the lens length to widen out the field of view further. As I do this, however, I'll start to see a significant distortion on the vertical elements in the scene. Now, Rhino has a 2-point perspective projection that can be enabled to correct this, but I would suggest that it's easier to manipulate the camera whilst using the ordinary perspective projection, and then switch to the 2-point perspective when the view is pretty much set up. So I'm just going to manipulate this view a little more, and in the top viewport I'll move the camera nearer to the wall, and in the right viewport I'll move both the camera and the target upwards so the view is more representative of a person looking straight ahead. Once I've got something close, I can then set the projection to 2-point perspective, and the vertical elements will now straighten out. With the view established, I can turn off the camera by using the F6 shortcut and save the view. I'll go to the Named Views panel, click on the plus symbol here, and save this as Render02, and this named view will save with the file. Let's now look at applying some materials to our scene. I'll change the top viewport to perspective and switch to the rendered display mode in both the interior and perspective viewports. I'm going to start to apply some basic materials. So I'll go back to the layer palette and unlock all of these layers, and then let's look first at the walls. I'm going to apply a new material here, so with the wall selected, I'll go to Properties, click on the Materials tab with the tube of paint icon, then the downward arrow here, then the plus symbol, and choose Import from Material Library. Then I'll choose Architectural, Wall, Brick, English Bond, and let's choose Brick Wall 3D Mortar. The Rhino materials with textures mostly use a mapping type called WCS or WCS box mapping. WCS stands for World Coordinate System, and by using this system, textures like this brick material appear at the correct size without the user having to modify the texture mapping. And box mapping works well with simple planar geometry. Now, of course, there are many occasions where custom mapping is needed to take full control of the texture. But for this video, I'll just be using the default proposition. I've already added a glass material in the previous session, so that we could see our geometry more easily. So next, I'll apply a material to the floor. Because I modelled the floor plate very simply, and I don't have a separate flooring layer on top of this floor plate, and, of course, the fact that I'm interested primarily in the interior view, I'm going to apply a wood floor material to the complete floor plate. So, with the floor plate selected, I'll go to the Materials tab, click the downward arrow here, then the plus symbol, and choose Import from Material Library. Then I'll choose Architectural, Floor, Wood, and let's choose Wood Floor Lighter Reflective, and that should do the job. I've now added more library materials, and I just have the chairs left. I've split out the chair layers by material type, so I'm going to select the objects in the orange shells layer and give these a new plastic material. So I'll click on the plus symbol and I'm going to choose plastic, and I'll set the color here, which of course is going to be orange. And I can vary this color slightly and then reduce the reflectivity and clarity to make the material less glossy. So I'll set both of these values to about 75%. I'd like to add a texture to the material, and of course it's pretty hard to see these chairs at the moment, so I'm going to isolate the layer that these are on. So right click on Shell Orange and choose One Layer On, and then in the perspective viewport I can zoom in, or even better, select one shell and use Zoom Selected to get a close-up view that I can manipulate. To add the texture, I'll select the object and then go to the Object Properties Material tab. And from Bump Texture, I'll choose a speckle texture. Now, as I zoom in the perspective view, I'll start to see this speckled texture here, and I can set this at various different sizes. What I want for this is just for the speckle texture to break up the reflection slightly. Now, obviously, in the final view, I'm looking at the chairs from quite a distance, but nevertheless, adding the texture will be helpful, particularly when we ray trace the image. I'll turn all the layers back on again. So from the layer toolbar here, I'll select All On, and then for the white shell material, I'm going to copy the orange plastic material and change the color. The easiest way to do this is to open the Materials panel. So I'll click on the small cog icon here, go to Show Panels and select Materials. I can see the plastic material I've just created, and I should give this a proper name so I can find the material later on if necessary. So I'll call it Plastic Orange, and then I'll right-click on this orange material and select Duplicate. I'll call this new material Plastic White, and then all I need to do is to change the color. So I'll make this white, and I'll add just a small amount of grey to this so that it isn't 100% white. Lastly, I can go to the aluminium layer here, select the objects, and add a new metal material. The Rhino materials are physically based but simplified, so only the relevant controls for each material type are displayed. So metal materials have just a simple slider from rough to polished and a color here. And these colors will be set by default to some standard metals. So I'll choose aluminium and then vary the level of polish to taste. Now I've added some basic materials, the next thing I want to do is to look at the lighting. At the moment, Rhino is using its default lighting system, which is essentially that of a photographic studio. This is a good starting setup for product design scenes, for example, and is set up with a grayscale 360-degree environment created from an HDR image. This studio environment is used both to light the scene and create the reflections, whilst the white background is controlled separately. I'll start by adding a sun, and so I can see the changes a little easier, I'll zoom out in the perspective viewport to show the exterior. I've already got the sun panel docked on the right here, but I can also access this from the Render Tools tab and selecting the sun icon here. I can turn on the sun and choose to set the position manually or by geolocation. I'll scroll downwards in the sun panel and set the location to London, and immediately the lighting and shadows will change in the rendered viewports. I'll set the date to the 9th of August, and if I move the time of day slider, then the lighting and shadows will move accordingly. Next, I'll look at the environment and background. I'll go to the Rendering tab and uncheck Use Custom Environment for Reflections and Use Custom Environment for Skylighting. And then in Background, I'll switch from Solid Color to 360-degree Environment. I'll now see the background change. So, at the moment, the default Grayscale Studio environment loaded into the background is controlling the background, skylighting, and reflections. So, next I'll replace this studio environment with the sky. To create the sky, I'll click on the downward arrow here and then the plus symbol and choose Basic Environment. Then I'll right-click on this new basic environment and select Edit. This pops out an editing window from where I can add a texture from the background image slot, and here I'll choose Physical Sky Texture. Next, I'll left-click on the Physical Sky Texture icon, and this will open another editing window, and from here I'll check Use Document Sun, which will create a link between the sky texture and the sun I set up earlier. So the sky will change with the movement of the sun. If I scroll downwards in this panel here, there are further settings that can be changed, but for now I'll leave these all at default. I'll then OK the changes to the physical sky texture and basic environment. In the two rendered viewports, I'll see the changes to the environment, and one thing to note here is that the ground plane that is enabled by default doesn't have a material applied to it. It's just a transparent shadow catcher. So I'll see the bottom of the sky texture, which is black, through the ground plane. I'll click on the ground plane icon and choose Use a Material in the ground plane settings. This will initially be the white default material, and now in the rendered viewports we'll see the ground plane running out to the horizon. If I zoom out a little in the perspective viewport and go back to the sun panel and move the time of day, I'll see the shadows move and the sky darken at dawn and dusk. Looking now at the interior viewport, I've now set the time of day to produce some interesting lighting in my scene. And to show more detail, I really need to switch the display mode to Raytraced. Before I do this, I should explain that with an interior scene, I'll get significantly better results by creating an offline render than I'll see in the Raytraced viewport. If I switch to the rendering panel, I'll see there are some preset quality settings that I can use for an offline render. And scrolling to the bottom of this panel, I'll see a setting for samples which controls the number of passes in the Raytraced viewport. And if I select Override Production Render Quality, the number of passes for the offline render too. I'll be using this override later. I'll switch to the Raytrace viewport and the scene will start to render to the default 1000 passes. With an interior scene, it may help to turn off the denoiser, which I can do by left-clicking on the star icon here. There will naturally be more noise in an interior scene, as much of the illumination is indirect, and using the denoiser may create a smudging effect, blurring detail in the process. If I want to speed up the Raytraced viewport, I can reduce the number of passes by clicking on the 1000 value here and changing it to, for example, 500. And note that this also changes the samples value in the rendering panel on the right here. So the next time I Raytrace a viewport, the render will stop at 500 passes. Having said this, I really need more passes for an interior scene, and this is best done via the offline render. I'll maximize the interior viewport and run the Raytrace display mode just to make sure I'm happy with the scene. And I'll turn off the denoiser. The scene looks fine. It's very dark, but this is something that can be corrected shortly. I'll switch back to the rendered display mode, and in the rendering panel, I'll set the samples to 2000 and check Override Production Render Quality. I'll render out at viewport resolution to start with and left-click on the render button. This will open the frame buffer and I can see the offline render progressing, and I'll see that this is set to stop at 2000 passes. I'll turn off the denoiser, and in the tone mapping tab I'll switch from clamp to logarithmic. This will create a much better exposed image without over brightening the light areas such as the windows and sunlight patches. If necessary, I can adjust the exposure value here too. Moving on, I've now changed the sunlight position slightly, set the rendered image to be larger whilst maintaining the viewport ratio, and increased the number of passes to 3000. I'm going to check transparent background, and that will automatically create an alpha channel to crop out the background when I save out the image in a supported file format. And I'll render again. I'll keep the denoiser on for now and once again set the tone mapping to logarithmic. To see the alpha channel, I can click on this icon here, and the background visible through the windows is now transparent. And this gives me an opportunity to replace the gradient sky with, for example, a photographic image. When the render finishes, I can save this out as a TIFF file. And if I then open this file in Photoshop, I'll see that the areas inside the windows are now transparent. And if I have a second image that is cropped accordingly and has the same pixel width as my rendered image, I can copy this onto the clipboard and return to the first Photoshop file. From here, I can create a new layer, place it underneath the rendering, and paste in the image. Finally, I can lock the top layer and use the Move tool to adjust the position of the new background before saving out the image. So that's about the end of what I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button, and remember that to keep up with the latest developments in Rhino, you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and all its key plugins, so check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.